So the extra here is to go back again and pick it up, start afresh. No, it will just show warning. It's just warning, it will tell you. It will show you warning. So it goes back and had this one, 6. And then goes back and had this and gives us what? 10. All right. Sorry, the thing went off. Let me try to put it all back. Dolapo. Not seeing what I'm presenting. All right. So now let's be together. You can also perform these operations, different operations within, the vector itself. If you do this, it's just give you, 27, 7, and then this one, the original one that was created with this vector, will also be brought in. So we can actually append different vectors also together. Okay, you have at least tried that one. Okay, now in creating vectors, please let's be together. There are other ways to create vectors apart from the use of C. We can also create what we call sequence. When you create a sequence, it's a kind of a vector as well. Are we together? And we can create sequence. Sequence in mathematics, what are they? What's a sequence? A sequence is a one-to-one correspondence with set of natural numbers, right?
It's a function.
It's a function. So that's why I say it's one-to-one correspondence with set of natural numbers. So it's a function. So meaning that we are talking about f, that is depending on n, where the n is what? Where n is what? N is natural number, right? And such here, are we together? So we are going to be having it coming out like what now? As, yes? Can we see it? Okay. Okay. All right. So you can, when f is, so this is as f underscore n, yeah, subscript n. So meaning that if I have, f1, the next is 2, 3, right? So for instance, if you want to give a sequence 1 to 20, since you want it to increase by 1, you can just say 1:20. If you run it and let's see what you have. 1 to 20, just run it. What do you have? What do you have in your console? What do you have in your console? 1 to 20, isn't it? But you know that you cannot always have your sequence increase by 1, right? Like the first one I gave, 1, 3, 5, 7. It's not increasing by 1. When there is need for us to specify different step increase, then we use the function seq, which is sequence. Are we together? Sequence. And then once you type sequence, just the same way I was trying to suggest to you the other time, then in the function sequence, the arguments are from. Is that okay? You tell us where you want it to start from. Say we want to start from 1, for instance. So let's say we want it to stop at, when do you want it to end? At 20. Good. So step size now. You have to now say by what do you want it to? By 2. Now run this and then let's see what we have. You say it should start from 1 to 20 by 2. Let's see what we have. And like I told you, even if you don't specify from, to, and by, just with 1, 20, 2, R will take it as from 1 to 20 by 2, because that's the argument, the default. So what do you have? Up to 19. It's not including 20. Why? Because once it should add 2, it will go to 21. But sometimes you want to start from 1 and you want to end at 20 still. But in that case, you will have to determine the step size that makes that happen, right? Are we together? So if you want to do that, so you can, but you still want it to start from 1 to 20, and you don't know what the step size is. Are we together? And maybe you just need, so you can do sequence. So from equals to 1 to equals to 20. This time around, what other thing you can specify is the length out. How many numbers do you want to generate between 1 to 20? So it will now determine the step size for you. Let's say you want 100, 10. So you say length out dot out equals to 10. So do that and let's see what happens. Run that and let's see what happens. What do you have? You have decimal, right? It's expected, isn't it? Because you are saying that you want 10 and you want the number to run from 1 to 20. 1 and 20 inclusive. If you were to do that mathematically, manually, you will have to determine what the step size should be, isn't it? Because it's of equal step size. So you have to determine that mathematically, originally for yourself. But R has determined that for you. But we are mathematicians, so I believe that if you want to do this, you know what to do, isn't it? Because it's same step size, you want F1, for instance, to be 1, right? Are we together? Your F2 is now what? 1 plus H. F3 is what? 1, because another step size of what? H, so that will be 2H now. So F10, because you want 10, isn't it? You want 10 outcomes. So that will be 1 plus 9H. Don't forget that 1 plus 9H should be what? Should be 20, isn't it? That is the 10th should be what? 20. So 1 plus 9H will now be what? 20, right? So that means 9H is what? 19. And H will be what? 19 over 9. That's your step size. Are we together? So that's what is going to be adding. That's why you said it was decimal. And then that's why I said it's expected. Are we together? Do we get that? All right. Thank you. Let me see 1 or 2 things I can do. And then because of time, we'll continue this class tomorrow. Just few more things within the short time that we have to close for the day. My time is actually up already, but I am trying to just all right, while he's trying to help us, are there any questions thus far? Questions thus far? I know people are there to help us to get what we are doing. No, it's not showing what I want to do. Like, I'm still using this slide. All right. So we have seen that we can also reverse. For instance, you can say from 20 to 1. If you do that, it can reverse it. Are we together? So it will start from what? 20. And it will go backwards. The same way we did the other time, just like we did 1 to 20, I can do 20 to 1. So it will go backwards. It will reverse it. It will reverse the order. All right? Okay. There is also something we call repetition. You use rep. So you sometimes, you have members of, or you have the component of your sequence, being repeated, and you don't want to be typing every now and then. You can just specify that, R should repeat. You can use rep, and then once you put rep, then type that rep x equals to 1 times equals to 4, and let's see what you have. Let's see what it will do for you. That means it will repeat 1 how many times? Do that and let me see what you have. 1 in 4 places, right? Can we try the second one now? So let's try the second one. This is a vector this time around, right? And we want to repeat that vector how many times? How many times are we repeating it? Please let's show the slide so that people can work with what we have there. So this is a vector 3, 62, and then 8.3. You have to repeat that vector 3 times. So what do you have? Now, when you are typing the vector, don't forget to include your C to combine those numbers together. And don't forget to use a small letter C. If you use capital, it will give you wrong. It will give you error because R is case sensitive. So what do we have? 3. And it repeats itself like that. So the whole vector will be repeated as a whole. 3, 62, 8.3, then 3, 62, 8.3, then 3, 62, 8.3. Are we together? All right. Now let's see this one. Rep the same number and now say each equals to 2. And let's see what that will do. Each. So that means, unlike the first one that we did, that took the whole vector as 1 and repeat it as a whole like that 3 times. So it's not going to be repeating each entry twice. So what am I expecting here? 3, 3, 62, 62, 8.3, 8.3. Do you understand? All right. We can combine both of them. We can say repeat that 3 times, each equals to 2. So combine the previous steps and the current one. Rep that same number times equals to 3, each equals to 2. And let's see what we have. Yes, please, let's project it. Let's project the slide. So we are combining step 2 and step 3. So what do we have? We are having 3, 3, 62, 62, 8.3, 8.3. Then it does the same thing again. Are we together? So it goes inside to repeat each twice. Are we together? And carries out that entire step how many times? 3 times. Do you understand? So those are just different ways of and then sometimes you have your vector already, and you have typed different numbers and you want to sort and increasing. Are we together? We use a sort function. And then decreasing first, or we say decreasing true. So if you say decreasing first, that means it will do what? Arrange it in order. So like I've told you before, that R, functions in R have arguments, and the arguments must be strictly adhered to. Now, because if you go and write increasing, you say increasing true, because you don't want decreasing false, then it will give you error, because it was never programmed with that. It's a language. You must be able to speak its own language too. So if you type increasing true, it will give you error, because it was never programmed with that. It was programmed with decreasing. So you can either now use decreasing true or false. So if you are, then decreasing should be what? False, right? Yes. All right. Do we get that? Do we have the right answer also for that? Was it sorted in decreasing order when you said decreasing equals to false? Who didn't have that? Increasing order when decreasing is false, right? Great. All right, thank you so much. Now, I've told us the other time the way we can find the length of a vector. We can put the length of the name you use to save that vector, length, and then it will give us whatever length that vector is. Okay, for time's sake, we are going to stop because do you get that? Whichever vector you have saved earlier, you can access any part of that vector. Maybe you want to access the first two, you can say Shade 1 to 2. So it will access the first two. Let's say you want to access the first, the third, and the fifth. Then, so that's where I'm going to stop. Let's say you want to access 1, the first, the third, and the fifth. For instance, if there are up to 5, then you see, combine it, and you say 1, 3, and 5. So it's going to access, it's going to help you get what? The first, the third, and the what? And the fifth. Is that okay? All right, so we can try all of that. Okay, so here we come to the end of today's R class. We'll continue tomorrow by God's grace. Okay, thank you so much. And and on this note, we are bringing today's sessions to a close. We want to appreciate every one of us for staying to the end. I wouldn't know if Prof has something to say to close the day as we return tomorrow by God's grace. Please, for us to start tomorrow, Prof, sir, we are ending today already. I wouldn't know if there's something to say to end the day as we go.
Thank you very much, everyone, for your attendance. This attendance is very important because people that finish are the ones that will get certificates. Now, if you don't complete, it means that we will not give you certificates of attendance. So we have seen that so that we note people who are not around, and then people who were able to sit. Yeah. Okay. So, okay, no problem. I think we have noted people who are not around. Some have noted some. Then, I think we will not allow people who didn't attend throughout to get the certificates. Now, let's make sure we come around tomorrow as early as possible. Tomorrow is the last day, but I think we can still do a lot if we start on time. Because today, tomorrow